All right, students, so this is medal number 4 in our reactivity lab. So again, the question that we're trying to answer is which of these metals is the most reactive? This video is going to focus on the metal of calcium, and I'm going to go in order and I'm going to react it with silver nitrate, lead nitrate, copper sulfate, hydrochloric acid, and potassium chloride, okay? So here I've got my calcium in my 5 reaction wells. Calcium is a metal. It's an alkaline earth metal. It's in the second group. And so let's see how it reacts with our solutions. So the first reaction is with silver nitrate. And you can see right away that the calcium is starting to bubble up. There's a gas that's being produced. There was an unexpected color change because it got really, really brown. Okay. I don't feel a temperature change, but you can see how that got, ooh. Woo-wee, look at that. Took a minute to get going, but man, that's kind of violent. I don't know if you can hear it, but it is sizzling. And it's definitely making a mess. Ooh-wee, that was kind of violent. Look how gross that looks. So that was calcium and silver nitrate. So hopefully you guys can write down some observations about that. It looks like it's still kind of smoking a little bit. Okay. It's definitely hot on the bottom for sure. It is hot on the bottom. So there was a lot of evidence that a chemical reaction took place on that one. It got hot, it bubbled, it smoked, it fizzed, it popped. All the things happened on that one. That was pretty exciting. So let's do the next one. The next one is lead nitrate. So our second solution is lead nitrate. Let's see if the same thing happens with our lead nitrate. I'm gonna move this piece of copper, or the calcium for now. So again, this is calcium and lead nitrate. Let's see if it reacts the same way. Oh, there it's starting to go. So right away, you can see that a gas is being produced, because you can see it start to bubble up. And here the reaction is really getting going now. You can hear it. You can hear it reacting. Okay, so that one reacted much the same way as the first one did. That one actually might have like melted the reaction plate a little bit. The reaction plate's kind of squishy. So it is very, very hot on the bottom as well. So that was a very exothermic reaction as well. So that one was a very violent reaction. So hopefully you guys can write down some observations in that data table. That was exciting. All right, the next one. The third solution is copper sulfate. So again, this is copper sulfate and calcium. And let's see if it has the same type of reaction. There it's starting to produce a gas. I bet it's going to do something very similar as the first two. So we can see that calcium is definitely the most violent out of the ones that we have seen. So far you can see you have a lot of evidence that calcium is very reactive. And so your job next week is going to be to decide why is calcium the most reactive. So you might want to be giving that some thought as we watch this reaction take place. Not quite as violent as the first two, but there's definitely some bubbles happening. So a gas is definitely being produced. Let me see if I can feel the bottom of this one. This one doesn't feel as warm as the first two, so I don't feel any change in energy on that one. It's still producing a gas, so the reaction is still happening. So usually the reaction will continue to happen until either the liquid is completely used up or until the calcium metal is completely used up. So I bet if we were to go back and put more liquid in one of these first two, that we would get the same type of violent reaction. Because it looks like, if you notice, there's almost no more liquid in these first two. So the reaction continues to take place until one of the reactants is completely used up. That one is still going. There, we got a big bubble. That one took a while, but that one's getting pretty reactive as well. Wonder if that one will be hot on the bottom now. Yep, that one got hot finally. So that one's a very exothermic reaction as well. It just took it a while to get going. All right, and while that's going, I'm going to go ahead and move on to our next solution. So our fourth solution is the hydrochloric acid. So let's see how calcium reacts with the hydrochloric acid. So this one is very violent as well. This one got going pretty much right away. You can hear this one. There's a lot of little explosions. There's a lot of gas that's being produced. You can kind of see the smoke coming off of it. Ooh, that one is a very fast reaction. So you can see like the copper one is still reacting, but the hydrochloric acid has already been used up. So that was a very violent, very fast reaction. And I bet, yep, that one was also very hot on the bottom. So that one was also very exothermic. Okay, and the copper is still going, friends. All right, let's add a little bit more hydrochloric acid just for fun. Oh yeah, that's a very violent reaction. And the copper is still going. All right, I'm gonna set that aside, still in your field of view. We've got one more reaction with calcium. I just want to put it in a reaction plate that's kind of clean so it doesn't react with the other ones, okay? All right, so our last reaction is the calcium and the potassium chloride. So let's see what happens between calcium and potassium chloride. Let's see if it's the same as the others. And we're gonna give it a minute because we can see that there's a gas that's starting to happen. So the reaction is getting going. Just like the other ones, there's a gas being produced. It's starting to kind of smoke. There it goes. And once that reaction took place, that reaction was very, very fast. So that was once it got going, that was a very fast reaction. So let's put a little bit more potassium chloride in there, see if we can get it to react again. Yep, there it goes. So again, the reaction is going to continue to go until all of the liquid is used up. So you can see that calcium was definitely the most reactive out of the ones that we've tested so far. You have a lot of physical evidence to support that. All of them were exothermic. All of them had little explosions. All of them produced a gas. So there was a lot of evidence that a chemical reaction took place there. So make sure that you guys record that in your notes and then join me for the reactions of magnesium.